Welcome to my webinar, How to Derive Statements from All Your Data Sets. I'm Alex from the Customer Success team, and today I want to show you how you can use the information from other documents in your collection in a direct or indirect way to improve your product descriptions. What am I talking about exactly? So let's take a look in a standard collection. In this collection, you see different smartphones. As you know, every smartphone gets its own text, as here, the Apple iPhone XS, the right side. The source for the text is the provided data for this single product. So the JSON object you can see here. There are data fields for storage capacity, display size, and so on and so forth that are used here in the text at the right side. But sometimes it can be fruitful to broaden your view and also use information from other products, as here, Xiaomi, Galaxy A3, and so on, in your text. So in your text for the Apple iPhone XS. And the key to do that is a specific node type called analysis result. And yeah, that's the node I want to show you today and I want to work with today. Before we switch to the tool, let's clarify what you can do with this node, and maybe even more important, why should you do that? The node helps you to classify smarter. So to say how good, big, small is the current product compared to all others, or to say how many products have the same quality, how many don't. A good product description contains interpretations of the values and helps the readers to understand the advantages of the products. Values are always seen in the context of others. So for this first example, that means a display size of 14 inches can be interpreted as big because in the full range of sizes, look in all the smartphones, 14 lies in the top half and maybe is the maximum value. An example for the second thing, how many products have the same quality. Yeah, a smartphone in gold can be seen as special because most of the other smartphones are black or white. If most of the other smartphones would be gold, you would underline the information black instead. And the analysis result tool helps you to get this information in a dynamic way. So this first example is the indirect way to use the information. So we don't name the other display sizes. We don't name the other colors. We just use it to set the single information into a wider context. But there's also a direct way to use the information. Yeah, this way is to set references to other products, to be able to say which other brands do we offer, and to be able to say, yeah, maybe in which other colors the product is available. That's possible by looking into the other products of your collection. So let's see which data types the node can handle. I think you guess it. Numerical values as well as string values can be the source of an analysis result node. Yeah, here you see examples again, sizes, prices for the numerical values, and things like colors or additional brands on the string value side. So maybe you're asking yourself, okay, why should I do that? Or what's the new thing at the analysis result node? Because maybe you're using the information from the Analyze tab in the Composer, use the statistic to do classifications and interpretations. That's fine. That's good to do that. But the advantage of the analysis result node is the dynamic change of interpretations. So that means that the classifications and interpretations, they change automatically if the data sources are changing. So for example, if smartphones are getting smaller or bigger, the dividing lines for big or small are going up or down automatically. You don't have to take a look at it to do your research. It's done automatically if your data sources are changing. Or maybe you have some more smartphones, other colors in it, then your text will automatically update it and these new colors can be found in. Okay, perfect. So I would say now it's time to switch to the cockpit to show you what I have planned for today. Okay, let's first take a look at the data we will use today. We have two smartphones. We have two collections for different smartphone shops. So in shop 1, we have 13 smartphones from different brands. And in shop 2, we have 11 smartphones that are all from Fairphone. So this information will be important later. So let's switch to the composer now. So the statements I want to do with you today is a statement regarding the display size. We want to classify a specific smartphone into small, big, or average in size by using the context of the other display sizes of the other smartphones. And we want to have, or we want to do a statement that informs about other colors smartphones are available in one specific shop. Okay, so let's switch to the transform part. And yeah, before we start with the statements, I will show you where you can find this node and what's its basic features. Variables in it. So it's a normal node. You can find it under data. And at the right side is always, you see the menu of it. You can rename your analysis result node. If you take a look at the display size, you can name it display size. And then the next step, use analysis. Here you define the reference for the data field you want to take a look in. So let's click the drop down menu. So we have the possibilities shop 1, shop 2, and all collections. Okay. Okay, shop 1, shop 2, you have seen that, but all collections can't be found in the data sources. So let's clarify what these things mean. So the reference for the analysis result node is not the collections, but the folders you can create in the Analyze tab. Maybe you know that you can create folders, and in every folder you can filter for specific things. So you can say, use all data in this project, use only collections from language XY7, or use only collections, use only a specific collection. As you can see here, we have 3 folders, shop 1, shop 2, and all collections. And for our specific examples, that's helpful and important, because let's take a deeper look at it. For the display statement, it would be good to have a very wide range of values, because the more smartphones you have, the more values you have, the better is your classifying, the better is your interpretation of small, big, and average in size. It's not important that you just take a look at your shop because you want to say something about smartphones in general. On the other side, we have this other color statements that says you prefer pink, gold, or blue smartphones. Just take a look in our shop. You will find the right model. So in this case, it's not helpful to take a look at all the smartphones. Take a look at another shop, because maybe in this shop there aren't pink or gold smartphones, and then you're saying things that are not true. So for this statement, it is important just take a look into the data from a specific shop. And that's why these filtering options can be very helpful. Okay, later we would say, as I said, all collections here to have many values. And the last thing you have to enter is the specific data field you will take a look on. You will get the information from all your smartphones. So that would be display size. And now we get a result here that's not very big, not very good to get an overview here. So let's change to our presentation again so that I can show you which result you get from the analysis result node. Before I do that, I just see there's some more theoretical information I can give you. What is important for using the analysis result node, that's that all the data types has the same, data fields has the same type, strings or numbers, so you can't compare a number 7 with a string value as gold. That doesn't make sense, it doesn't work. So make sure that the values of one data fields are all of the same type. And the other thing that is important is that you have sufficiently filled data, because let's say you have 1,000 smartphones and the display size is only available in 10, and then you make this classification and this statistics on it, this won't help you. It's not representative. So make sure for the data fields you're using for the analysis result node that they are available in all cases, in all documents, or even in a big amount of documents. That's the result you get from an analysis result node. So first you get a number of values that can be found for this data field in all the collections or in the analysis folder you take a look on. You have the sum of all values, not so helpful in this case. You have the minimum value, the maximum value, more helpful, the average value, and the percentiles. And the percentiles, we will use the percentiles to do the classification of small, big, and average in size display. So let's take a deeper look at this percentiles result. First, what are percentiles? Percentiles give you an overview of the distribution of values and their frequency. It extrapolates the values to 100 values so that it gets you an information of the percentage number. The values are sorted in ascending order. So you remember we have 24 display size values, as you have seen here. But here, as I said, you will get 100 values. So a single value will extrapolate in the context of 100. So let's give you an example. Let's say 12 of the 24 phones had the same value, for example, 6. That would be the half of 24, equals 50%. And in this case, that would mean 50 positions would be 6. And now the important question is, how can this help us? So we can define the limit above which we say a smartphone is small, or the other way around, a smartphone is large. For example, we could apply the quite common 25th percentile for the lower limit. What does that mean? It means the 25th position from the bottom, which is 5.7. So it's 1, 2, 3, 4, 5, and that's the 25th position. So 25% of all values are below this value of 5.7 or equal this value 5.7. For the upper limit, we can use the 75th percentile that says 25% are above or equal to the number 6.39. And in our example, that would mean we define display sizes, or it would mean for the range of data we have at the moment that display sizes smaller or equal to 5.7 can seen as small, and display sizes bigger or equal to 6.39 can be seen as large. And that's handled automatically by the engine. So if the ranges, if the numbers would change, then maybe the borders, the numbers for this 25th percentile and 75th percentile would be different numbers. So we will use that in a few minutes, but let's take a look at the other information you can get from the analysis result node. So the values, as you have seen here on the second level, we have information for values and types. And in these values, you get in another format an overview of the data. So it says we have 3 times the value 5.8, we have 2 times the value 5.84. So yeah, and for numerical values, the other things is minimum, maximum, and percentiles are more helpful, but that can be very useful for, let's say, string values as colors, because then you can see, okay, which is a common color, which is a special color, because it just can be found, I don't know, one time, and so on. The last thing I want to show you is the data field types. So in here, you get all the information divided in a single format. As I have told you, it's good, or it should be guaranteed that all the information are of the same data type. But if not, the tool can help you, because let's say you would have only 20 values that are of number, then you could use that information. And the other 4 would be maybe empty or values that can't be handled in this case. Then the result of the analysis result node helps you, because you can specifically navigate to number and just use the information that can be handled. Okay. So we will switch to the cockpit again. So I've prepared some things here in the subgraph. So let's first do this thing with a big, small, and average and size display. So we have the result here that you have seen in my presentation. And the first thing we want to define is the 25th percentile. How can we do that? First of all, we're using this information from this data node. Hashtag display analysis. And now we have to navigate to percentiles. How can we do that? We're just typing in a point and then the number of this data field, percentiles. Now we have all the range of values. And what we want to get is the, as I said, the 25th percentile. And that's why we're referring to a special position that can be done with the square brackets. And I type in 25. And yeah, you have seen it before. 25 is the first quarter. What is important to know here is that it begins, the system begins at 0 with counting. So if I type in 0, I get the first position. So that means if I type in 25, I get the 26th position. That's fine, because then we'll later say, okay, it can be seen as small if the value of the display size is below this 25th percentile and not equal to this number. So that's how we can handle this. So for the other thing, for the 75th percentile, I just copy this expression and change it to 75. Again, so 75 is the 76th position. The 76th position is within the upper quarter. So for this percentile, we have to define the value has to be bigger or equal to that number that is calculated automatically. Okay, so now we have the borders for these percentiles. And the other thing is, yeah, we need the display size of the current smartphone we have to be able to compare it. And what we do here in this mapping node is we're using an if-else condition to define values, small, big, and average in size, and then use that information for a switch node and to trigger it. So we're saying if the display size is smaller than the 25th percentile, then we want to output small. Next round is else if the display size is bigger or equal to the 75th percentile. It should be seen as big. And then we're just as a fallback. So all the other stuff that's not big or small is average in size. We just can say, if that's not the case, else we have average in size. No, only average. So these are the things we have defined here. So it's small, big, and average, not average in size. So we're sending it to the switch node, and then whatever condition is true, it will get green. So in this case, we have 14.38. So that's definitely bigger than this number. So big display will be true for this example. Let's switch to the write mode and use that triggers. So small, big, average in size. Here again, so big gets green check mark. Let's switch to another smartphone. That's also big. Yeah, but that's above 5.7, but below 6.39. So it's average in size, and then maybe we have also a small. No, that's the small one. 5.7 is seen as small. So our condition, our rule set is working here. Okay, then let's switch to the other thing for the colors. Again, here for this color thing, we have to, we want to use the specific shop information. So I have two analysis result node, one for shop 1 for this folder, and one for shop 2. The first thing you have to do is we have to decide which information has to be used. That information has to be found in the data. So if we go back to the data sources here, you can see there's a meter information in it. Shop 1. So all the products from shop 1 has the meter information shop colon 1, and in shop 2, you're guessing it, I think you have data field shop value 2. So this information has to be in the data and has to be used. Also here, for this mapping node identifying shop, we have to use this information from the shop. So again, we're saying if shop equals, so I can use 1 or 2, that doesn't matter. So if shop is equals 1, then I want to use the information from shop 1, from this analysis result node. And we just have two options, so we can just set a fallback and saying in any other cases, we want to use the information from color shop 2. So in this example, we have from shop 1, Galaxy A3. So with 13 values, so the output we get is correct. So what we want to use now is this information from values. You have seen it later, before. So we just want to output the information that can be found here. Sure, minus the color that the current smartphone has. So because as in this example, we have a gold smartphone. We don't want to say here, we prefer pink, gold, or blue smartphones. That doesn't make sense because this smartphone is gold. So what we have to do in this mapping node is to filter for the colors that are not the current color. So how do we do that? We do that with the filter expression. We're filtering in this analysis result node, color analysis. And we have to refer to this values. Yeah, now we got the information in a way we can use it. Here we have all the colors, and the filter condition we define in the lambda expression is so X stands for every single element of this list. You have seen here, so 10, black, and so on. And then we're saying, okay, this information from the single object of every single object of this list just is allowed to be part of the final list. If it's not, the color that can be found here. So we're saying, we're referring to the single element with hashtags X. Then we have to refer to the value, which is called value. So this value is not allowed, so unequal to the color that can be found in the current smartphone. That's color here. So that's the information gold. And as you can see here, for this Galaxy A3, we have the information black, blue, and pink, but not gold. That's what we want. We have to send this information to another mapping node. And in this mapping node, we collect the information we want to output in our text. That's not count one type string value. We just want to have pink and gold and all the other colors. So we're using the collect expression. And we're looking for value here. And then you see the list black, blue, and pink. We send it to a group node, and then we can use that variable for our statement. Colors other, and we can choose the format, and we can choose the method that look for random order to have a little bit more variance. And we can say, as a conjunction for the last entry, use or. So you prefer blue, pink, or black smartphones? Just take a look in our shop. So in the Fairphone, for the Fairphones, we don't have pink smartphones, just gold and blue. So for black, we get gold and blue. And if I take the Fairphone 1, that is gold, I get black or blue. So this is working just fine. So the last thing I want to show you today is how that these results are dynamically changing with the data. So let's say we get a new smartphone in the Fairphone shop that is green. I just copy this Fairphone 11 and change some information. So that's UID 12, it's Fairphone 12, and the color will be green. I upload it. And now I get 12 smartphones. So let's see what happens. Now we have a new smartphone and a new value. But as you see, something is not complete yet, because if I regenerate this text, I still get black or blue smartphones. And that's a very important information. From time to time, you have to refresh your folders here, because the information that it's used is directly connected with this with the information from this analysis folder. So let's see shop 1. If we go to color, there's no green in it because we haven't refreshed it. So it's important to refresh it, and then the information is also used for your analysis result node. Shop 2, I refresh it, and here now we get the information green. And if I regenerate a text now for one of the Fairphones, I will get the information here green. You prefer green, blue, or black smartphones, and that's also the same for the black Fairphone 10, gold, blue, or green smartphones. Okay. So I'm finished for today. Thanks for your attention. I hope that you can use some information for your products. And I'm looking forward to see you in the next webinar. Bye.